So that kind of covers the things that I can cover in detail since I'm running out of time here. Some of the other things, the topics, some of these are actually fully developed. There's a very strong connection between our research in nuclear physics and the stellar energy sources. A lot of the people that did research in both. Hans Bethe figured out the proton-proton chain that powers stars, and he was one of the major developers and researchers in nuclear physics in terms of figuring out how the nucleus worked. This is the story that actually got this project. It was the first story that I had of this. This, Fred Hoyle writes about it in his autobiography, about how we had a problem trying to figure out how much there were of each element in the cosmos by computing how much they got cooked inside stars. And so one of the things he found was there was a shortage that could be explained if there was a special energy level, kind of like those metastable states I talked about earlier, in the carbon nucleus that enhanced the reaction rate for nuclear reactions involving carbon and stars. And they actually went looking for this level and found it. This was back in like the 1954-55 time frame. But that was one of the most fascinating stories that I ever heard about, and that actually was the one that got me started on this project. Other issues, general relativity. No matter what the crackpots say, general relativity is vital for the operation of the global positioning system. The solar neutrino problem. In fact, if you don't believe me, go and buy a book on how to write a receiver and write software for how the GPS system works, and they will all tell you about the GR corrections. Solar neutrino problem. We had a shortage of neutrinos from the sun. At one point, they reached the conclusion that the neutrinos were changing on their way out of the center of the sun. They've eventually done this. They've actually got Earth-based experiments where they have their detector on one part of the Earth, and then through the curvature of the Earth, they have reactors kind of spaced at different distances, and they measure the oscillation as they pass through the Earth. Degenerate matter. This is actually getting into an area where an interesting connection between semiconductor physics, like what's in your iPod or your laptop or whatever, all those semiconductor electronics, and white dwarf, degenerate matter and white dwarfs and neutron stars. There's a thing called the Fermi energy, which is important in both of them. And finally, exotic chemistry, because there's some every once in a while we find an element that someone cooked up in a laboratory that someone says, oh, we've identified that in some big giant star that's sitting there just cooking carbon with stuff. I think we found buckyballs. I believe we found spectral signatures of buckyballs in distant giant stars. Finally, some other things, that might be issues in the future. Again, neutron stars and neutronium, which I put in quotes because one of my professors said, neutronium, what is that? It's apparently a term that's really more used by the sci-fi geeks than the actual scientists. In terms of studying the nuclear equation of state in the laboratory, may have applications there. Dark matter, is it real? What is it? The current best guess is there's some other little particle that we haven't yet detected that may explain this missing mass that we seem to find evidence of in cosmologically. The cosmological constant and dark energy, are they real? Is it just this factor in Einstein's equations? Just what is it? And finally, the Pioneer Anomaly, which is another case of one of those things where they had this very long data set and they tried to sample it and do some research from it and found that there was a discrepancy between where they thought Pioneer should be based on the theory of gravity and where it actually was. And it's a very, very tiny discrepancy. In fact, it's so small they're not even sure if it's real. It may be an accumulation of errors. Actually, a gentleman at DragonCon, where I last gave this talk, he did a very nice talk on that where they're not quite sure. It could be just some noise in the measurements. So anyway, to wrap up, not all science is extrapolated into the cosmos. We like to say, well, maybe the universe is different out there, or maybe it's not different out there. But a lot of it, we made measurements where they impact how we understand science on the Earth. A significant amount is interpolated from the cosmos into applications back on the Earth. General relativity, probably one of the biggest ones. The science you know determines the technology you can achieve, and astrophysics can provide a laboratory for leading-edge physics. And I'm wondering about a sci-fi story idea. Whether this would have, been an interesting sci-fi story. References, some of the books that I've used here. These are sort of my big meta references, which pointed me to other things. This is a fascinating history on the analysis of Starlight, 150 years of astronomical spectroscopy. The Riddle of the Gaseous Nebula talks about the discovery of nebulium, rather. Home is Where the Wind Blows. Fred Hoyle's autobiography talks about the carbon-12 resonance, which is a very interesting story. The Principles of Stellar Evolution and Nucleosynthesis. This is actually my advisor's textbook. I had to put that on there. The Cosmic Century, History of Astrophysics and Cosmology. Kind of a high-level book, but a fascinating look into the detail. Actually, a lot of these, this paper and I think this paper both talk about the theme of this talk, that astrophysics provides an insight into fundamental physics. Data sources, National Solar Observatory. My Newton's graphic is from a gentleman at Virginia, University of Virginia. Space Telescope provided my nebula thing, and the flash spectrum is thanks to Brian Dennison of University of North Carolina, Asheville, who provided some of the solar spectra that I used. And finally, if you want to read more details, including a lot of details that I just didn't have the time for here, this paper is available on the Cornell preprint server. The paper is number 0710.0671, or if you go to there and just type in Cosmos in your pocket, it'll find it. And I'm optimistic. I think that at one point I'm going to get the second version of the second part of this thing done. And that's it. Thank you.